Okay, welcome to the next section where we talk about something called the Trapezium Rule. The Trapezium Rule, you've actually seen this before at GCSE. Okay, so Trapezium Rule gives you the idea really of where integration comes from in terms of using it to find the area under a curve. So at GCSE, we might have done something like this. And we made 3 or 4 or 5 or something like that trapezia to try and approximately find the area underneath this curve. But because a trapezium is a polygon and it's got straight sides here, it won't give you a perfect answer because depending on how you draw it. So here it looks like it's a bit hard to see really, but it looks as if maybe y1 might be on the curve. Yeah, it's hard to tell. But unfortunately, the idea is that depending on the shape of it, concave or convex, the area of a trapezium is not exactly the same. But if you have lots of trapezia, you can get a pretty good answer for what the area underneath the curve is, which is essentially what integration is. Integration is when we do this, but they get infinitesimally small. Okay, that's when you get like the correct answer. But for this question, using the trapezium rule, we're sort of showing where it comes from. Okay, so the area in this situation, well, you use the area of a trapezium, which is half, and then you have, well, how did we present it at GCSE? We normally did half of a plus b times by height. So that's just another way of writing it there. So y0 is your a number, if you like. And y1 is your b number. So if you tilt your head, think of the trapezium the other way around, that's the two parallel sides. This here is the height. Okay. So you've got one of them, and then you've got the other one, and then you've got the other one. Yeah. And you can actually do a little bit of sort of playing around with this. You can take a half h out because that's in everything. And then you notice you have a y0, two y1s, two y2s, and one y3. So why does this happen? Well, because if this is your trapezium and then you have another one, you're sort of counting this part twice. Okay. Whereas at the ends only appear once. So what we do is we make this into a rule, and this rule appears in your formula booklet. So what this is saying is the area underneath, integrating the curve basically between a and b, so between two x limits, is the same as a half of height, or height over 2, multiplied by the first one, so the first y1 value, and the last one, and then for everything in between, there's 2 of them because you double up, so they get used twice. This is what appears in the formula booklet. Okay. Main things to watch out for is that this height is actually the horizontal distance between them, between the trapezia on the x-axis. People get a bit confused about that one sometimes. Whereas these y values come from putting an x value in and getting the y value, so they're not too tricky really. A quick example: so between 1 and 3, x squared. So x squared looks like that, and we're talking about between 1 and 3. If we wanted to use 4 strips, well, the strip means like that. That's 1 strip. That's 2 strips. Excuse my awful drawing. That's 3, and that's 4. So 4 strips means 4 pieces. Okay, 4 pieces. Actually, there are 5 different y values. Okay, so watch out for that. It means 4 different pieces. Well, if we're going between 1 and 3 and we want 4 different pieces, how wide should those pieces be? Should be 0.5 because you've got 2 divided by 4. So your h here will be 0.5. Okay, then what about your y1, y2, y3, y4, y5? What about those? Well, you just need to put those numbers into this one here. So you start with the ends And then you've also got each of those key values in between. So notice there's 5 numbers here when there's 4 strips, okay? Because a strip has a left and a right. You find out these numbers. And now this, for example, would be your y1 in this case. This is your y2. Oops, that's your y2 and your y3, your y4, and your y5. And the formula says we add these together. We add these together and multiply by 2. And then we add that one, and we add that one. And when you've got that answer, we do multiply by that whole thing by the height over 2. Okay? So it's quite a nice type of question, actually. And it gives you some intuition as to where integration comes from. But obviously, this answer is not the exact answer. Yeah, you know it's not the exact answer, by the way, because if you actually integrate it, you get that one there. And if you put 3 and 1 in, you'll get something slightly different. So you would get what, 27. What are we doing? X squared using 4 strips. So the area equals that one there. Okay, so you get 27, and then you get 9, wouldn't you? So you'd end up with 9 minus, and if you put 1 in, a third. So the answer is not actually that. The real answer is 8 and 2/3. But you notice how it's really, really, really close. In fact, in this case, this gives you an overestimate. It gives you an overestimate because of the shape of the curve. Okay. So a question might look a bit more like this in terms of being realistic with the difficulty. So here's the function. Complete the table. So that's a nice one because you can see they want you to put that number into there. So you work that one out. You want to do 4 decimal places. And then it says use the trapezium rule. So we're going between 1.5 and 1. Use the trapezium with all of the values. 1, 2, 3, 4, 5, 6. So there's going to be there's going to be 5 different strips. And if you're going between 1 and 1.5, okay, that means if there's 5 different strips, that the height is going to be 0.1. Using the height as 0.1 and all these numbers here, we should be able to get that one there. Okay. If you do it a slightly different way, that might be fine. You might shuffle the end next to the start. That's sort of what I would do. But that's what's in your formula booklet. Okay, so another example. So find the exact value. So if they say something like this, what they're alluding to is that the trapezium rule is not perfect, and we saw that just before, but it is pretty close. So find the exact value. They actually want you to integrate, and this one is in the formula booklet. Okay, so the value between pi over 3 and 0, if you use the formula booklet, you will get this one here. And you put the number in and you get this answer here. So if it's something that you have, like an integral that you don't know off the top of your head, there's a good chance it might be in the formula booklet. Then what they want us to do is to use the trapezium rule with 2 strips. So there's 0, there's pi over 3. Easier if you sort of draw this out. 2 strips. So we're going to have one piece like that and then one bit like that. So we need the middle, don't we? So that's going to be, you could do half pi over 3, but that's the same as pi over 6. So this is like your y1 value or y0 if you prefer. Here we would say it's y0. That's the first value. This is the one in the middle that you're going to have twice. And this is the one at the end that you're going to have once. And you also need to know what the height is before. So the height is going to be pi over 6. And if we do all of that, we get this answer here. Yeah. So you do need to actually work out what those y values are. They haven't been given to you. So to find those y values, you put 0 in here, and then pi over 6 in here, and pi over 3 in here to get your table of values. Let's have a look what happens if we use 4 strips. So 1, 2, 3, 4. Yep. So pi over 6, half of that would be pi over 12. And then this one here would be 3 pi over 12. Okay, that's what the third one will be. So you're going to use these x values to get your y values, okay, which are all up here. but the height will be different. If you're using more trapezia, the gap between them has gotten smaller, so the height would now be pi over 12. Okay, so a half, so that's a half of the height. Okay, and now you've got more pieces there in the middle because there are more strips. Notice that the 1 and the 2 are the same because the start point and the end point are the same again. And you get a slightly different answer. Okay, so find the percentage error in each estimate. So these are not correct. We said that these are not fully correct because the trapezium rule gives you an overestimate or an underestimate. This is the real answer from integration. So you need to find out this value here, and then we need to compare. And percentage error, you're looking for the difference divided by the original. So what do I mean by the difference? I mean, if you do this one, take away this one, or vice versa, and then you divide it by the original or the correct answer, which is this one here, you should get these two answers. So you should just pause the video and check that you can get those answers there for a moment. So this one, take away this one, or the other way around, and divided by the actual answer, the original, should give you 5.6. And then the same, but with these two, should give you 1.5. Okay, so pause the video then and have a go at this one here. And as I said, it tends to be that they give you something a little bit trickier for your y equals. But read the question carefully, pause the video and have a go, and we'll have a look together in a moment. Okay, so the first part wanted us to just use the trapezium rule. So 1 mark here for clearly attempting to use it. And we get 11.25. And it did say 2 decimal places, so you should say to 2 decimal places. Explain how it can be used to give a more accurate approximation. This is one of the easiest marks that you can get asked if you know what to say here. So how can you make it more accurate? You can make the trapezia smaller or narrower. And all of these things basically mean the same thing. So increase the number, use more of them, make h smaller. Well, h will be smaller if you use more of them. So that's what all of those things there mean. And finally, use calculus. So calculus means integration or differentiation. So in this case, it's going to mean integration. So use integration to obtain an exact value. That means we're looking for maybe something with surds or logs or something like that. So that's a hint that we'll be doing integration rather than the trapezium rule, which will give you lots and lots of decimals. Okay, so using a suitable method to integrate there. And this was in terms of E. So the reason why they're saying exact form is because we're using E. And that takes you towards the end of using the trapezium rule. So the trapezium rule really gives you an intuition of where integration comes from. It can give you an overestimate or an underestimate, and sometimes questions are linked to comparing the integration answer, the exact area, to the area from the trapezium rule.